Hello everybody. In this example we're going to talk about bottlenecking. And bottlenecking occurs when you have a production process where there's different departments, and to finish a finished good and be able to sell it, that good has to pass through all of those different various departments. Well, not all goods require the same exact amount of time in each and every department, which means there's a department along the production process where production, that assembly line, stalls, or they call it bottleneck because a wine bottle gets skinnier at the end, so the wine coming out, like not as much can flow once it hits that smaller bottleneck. In this case, we have a example where bottlenecking could occur, and it's for Della Simpson Incorporated, who sells two popular brands of cookies, Della's Delights and Bonnie's Bourbons. Both cookies go through the mixing and baking department, and Michael Scherer, their vice president for sales, believes that at the current price, they can sell all of its daily production of both brands of cookies. Both cookies are made in batches of 3,000, and in each department, the time required per batch and the time available for each day are as follows. So, in the mixing department, for the Della's Delight, it takes 30 minutes to mix one batch of cookies. It takes 15 minutes in the mixing department to mix one batch of Bonnie's Bourbons. And in the mixing department, they have enough labor force to put through 660 hours of labor per day. 660 minutes, of labor per day. In baking, Della's Delights takes 10 minutes to bake for each batch. Bonnie's Bourbons takes 15 minutes to bake for each batch. And in total, the baking department has 300 minutes of labor time available to them each day. And then we have the profitability information for each brand of cookies. Della's Delights sells for $475 a batch. It costs $175 in variable cost to produce. Therefore, the margin on Della's Delights is $300. Bonnie's costs $375 per batch. It has a variable manufacturing cost per batch of $125. That product's margin is $250. So Della's is the more profitable line. Why don't we just make all Della's? Well, if we made all of the Della's that we possibly could, it's entirely possible we're not maximizing the productivity of our different departments. They take much longer to mix and not very long to bake. So if we did that, we would have a situation going on where we'd be using up all of the mixing department's hours and not all of the baking department's hours. We'd be paying people in the baking departments to sit around because they're not working. So there has to be some kind of way where we can mix this up, where we can make sure we're using up all our resources, using all the available minutes that we have in each one of these departments, and coming up with the maximum amount of product we can output and the maximum amount of profitability. And the best way to go about doing this is to do a little elimination by addition. And elimination by addition is going to require us to set up a linear function for each department. And the first one that I have is the mixing department's function. If a batch of Della's Delights takes 30 minutes to mix, if a batch of Bonnie's Bourbons takes 15 minutes to mix, and if the entire department has 660 minutes of capacity available to them each and every day, we can set that formula up as 30 times D plus 15 times B equals 660. So that could be our linear function for the mixing department. For the baking department, same thing. We are going to have 10 minutes of baking time for each batch of Della's Delights. We'll call that 10D. We have 15 minutes of baking time for each batch of Bonnie's Bourbons. And that department has 300 minutes of available capacity available to it each and every day. So the formula for baking department could be 10D plus 15B equals 300. And now we can use elimination by addition to solve for one of the two variables, either D or B. In this example, I am going to solve for D. What am I doing here? Well, in elimination by addition, you have to reconfigure one of the formulas so that when you add the two formulas together, one of the variables disappears. And we have 15B under both mixing and baking. So if I find a way to just make one of those negative, when I add them together, the B's will cancel out. 15B plus negative 15B is 0B. It's gone. So I'm going to multiply the baking formulas, so the baking department's formula by -1. And in doing so, it changes from 10D plus 15B equals 300 to negative 10D minus 15B equals negative 300. And then when I add them together, these two formulas, the B's do cancel out. And I'm left with 20D equals 360. And then if I solve for D by dividing by 20, I get the D equals 18. That means we should be making 18 batches of Della's Delights. Well, now I got to solve for B. So what am I going to do? I'm going to go back to either one of my formulas and just substitute that answer that we just got for Della's into the formula to solve for B, the amount of Bonnie's bourbons that we should make. So if we did the mixing department formula, we had 30D plus 15B equals 660 to start with. Well, we know that D equals 18. So if I just sub 18 in for D, I get 30 times 18 plus 15B equals 660, which becomes 540 plus 15B equals 660. And then I get the variable on the side by itself by subtracting out 540 from both sides of our equation. I get 15B equals 120, divide by 15, and I get B equals 8. Just for being thorough, let's do the other department, the baking department's formula. Their formula was 10D plus 15B equals 300, again because it takes 10 minutes to bake a batch of Della's Delights, 15 minutes to bake a batch of Bonnie's Bourbons, and that department has 300 minutes of capacity available to it. Well, if I substitute 18 in for D in that formula, it also solves to be 8. So what we're getting here is that with these two formulas, solved by elimination by addition, the optimal mix that this company can make is to make 18 batches of Della's Delights and 8 batches of Bonnie's Bourbons. It's going to be the best use of the limited amount of time they have available in each department, while taking into consideration the amount of minutes that it takes in certain departments for certain products, and can be scheduled around to avoid that bottlenecking issue. So what we're going to do here is we're going to go and we're going to make sure on the next slide that producing 18 batches of Della's Delights and 8 batches of Bonnie Bourbons does in fact use up each department's maximum amount of capacity. If we make 18 batches of Della's Delights, as we just solved for, and each one of those takes 30 minutes to mix, that means in total, those 18 batches at a rate of 30 minutes per batch are going to take us 540 minutes to mix in total. For Bonnie's Bourbons, we said we're going to make 8 of those. 8 times 15, the amount of minutes that it takes to mix one batch of Bonnie's Bourbons, comes out to be 120. When you add 540 and 120 together, you get 660. The total amount of minutes that's going to require is exactly the maximum capacity that we have in the mixing department. For Della's Delights, if each batch takes 10 minutes to bake and we're making 18 batches, 10 times 18 says that it's going to take 180 minutes to bake all 18 batches of Della's Delights. If Bonnie's Bourbons takes 15 minutes to bake and we're going to make 8 batches, 8 times 15, that's going to take 120 minutes to bake all of those cookies. And if we add those two together, we come up with 300. So we are in fact utilizing all of the available production capacity we have within both departments to the very last minute if we make 18 batches of Della's Delights and 8 batches of Bonnie's Bourbons. And what will our profitability be? Our daily contribution margin, if you will? Well, for sales revenue, we just take the revenue that we make per batch, which is $475, times the number of batches that we are going to produce, which is 18. $475 times 18 is $8,550. For the variable cost of making a day's worth of Della's Delights, we just take the variable cost of each batch, which is $175 over here, multiply that by the 18 batches of Della's Delights that we said we were going to make, and 175 times 18 is $3,150. And since contribution margin is always sales revenue less variable cost, that means that every day, if we do use this quantity, if we do make 18 batches of Della's Delights and 8 batches of Bonnie's Bourbons, Della's Delights is going to contribute $5,400 to our overall margin. What about Bonnie's? Well, we're going to make 8 batches of those. We intend to sell those at a price point of $375 per batch. 8 times $375 is $3,000. For variable cost, those 8 batches are going to cost us $125 a piece to make. 8 times $125 is $1,000, which means Bonnie's is going to contribute $2,000 towards our overall margin each and every day if we do use this setup. And in total, making cookies for Della Simpson Incorporated over here is going to have a contribution to our overall margin of $7,400 each and every day.